Today we are going to do the second session of JEE sequences and series. Now we are going to begin with a topic This is topic 3. Suppose there is an arithmetic progression in which the ratio of sum to n terms divided by sum to succeeding n terms is independent of n. So let's talk about an arithmetic progression in which the sum to n terms by sum to succeeding n terms is independent of n. So the calculation will be like this. So the numerator is sum to n terms and denominator is sum to succeeding n terms. So this is what we will get in the numerator. And in the denominator, this is what we will get. So if you simplify this, so we will get nd plus 2a minus d by 3nd plus 2a minus d. So if d is equal to 2a, then this ratio will become 1/3. So that means the requirement is that the series should be such that the common difference is equal to 2a. Suppose there's a question, find an arithmetic progression in which the sum of mn terms to sum of n terms is independent of n. So the question is, you have to find an arithmetic progression in which the sum of mn terms to the sum of n terms is independent of n. So this is the sum of mn terms. And this is the sum of n terms. So in the numerator, this is what we will get. And this is what we will get in the denominator. So D is equal to 2A. So when the sum of mn terms to sum of n terms is independent of n, that means D is equal to 2A. So this is another example of topic 3. Now we come to topic 4. In any arithmetic progression, the nth term is a plus n minus 1 into d. So that means the nth term is a linear expression in n. And the sum to n terms is n by 2 2a plus n minus 1 into d. So the sum to n terms is a quadratic expression in d. So this is very interesting information, that in an arithmetic progression the sum to n terms is a quadratic in n, and the nth term itself is a linear expression in n. Now whenever we get a question in which it has been told that the sum to n terms is a quadratic in n, such as 2n square plus 3n. Suppose we are told like this. So if you write S1, it is coming to 5. If you write S2, it's coming to 14. So that means the first term is 5 and the second term is 9. So that means the common difference is 4. So this is one way of doing the sum. You know Sn. So you find out S1, find out S2. S1 will be the first term, and the first and second term together will be S2. So second term we got it like that. So from there we got the common difference. So this is one way of finding out the series. There is another way. Suppose Sn minus 1, if I write like this, 2 into n minus 1 square plus 3 into n minus 1. Then the nth term will be Sn minus 1. So the nth term will be 4 plus 1. So you can see that the common difference is 4 and the first term is 5. So you can find it like this also. There is a third way to do this sum. The third method is, suppose we write 2n square plus 3n like this or like this. So if you compare this with the formula of Sn, if you compare these two, you can see clearly that A is 5 and D is 4. So this is the third method of doing this type of sum. Now we come to topic 5. Suppose you want to add the sum of the first n odd numbers. So the sum of the first n odd numbers, the answer will be this. So sum of the first n odd numbers, the answer will be n square. Like say for example, if we are doing a question like this, that there is a series 1 plus 3 plus 5 plus 7, and how many terms we should take of this series to get 1, 2, 3, 4, 3 to 1. So that means n square is 1, 2, 3, 4, 3 to 1. So n will be the square root of this. So that means we are getting n is equal to 1 1 1 1. Now there is a question. Prove that m to the power r is equal to sum of m consecutive odd integers. So what we can do is it's written m consecutive odd integers. So suppose the first one is k, then next will be k plus 2, then next will be k plus 4, and k plus m minus 1 into 2. So before k there will be a k minus 2. So this is not being considered. So what we will have to do is we will have to say that suppose we'll have to say like this, that there are k odd integers from 1 and m plus k odd integers from 1, and the difference between them is what is being spoken about. So that means the answer will be m plus k whole square minus k square. So that is equal to m into m plus 2k. So if m to the power r is m into m plus 2k, then m to the power r minus 1 is m plus 2k. Then k is coming m to the power r minus 1 minus m by 2. Now suppose m to the power r is 8 to the power 5. So this will become 8 to the power 4 minus 8 by 2. So k is coming to 2044. So if we write 1 plus 2045 minus 1 by 2, we will get 4089, which basically means that this series will start from 4089. So if m to the power r is 8 to the power 5, this series will start with 4089. Next we come to topic 6. Topic 6 deals with trigonometric series. Now, trigonometric series can be normal series like this. It can be a normal series like this, or it can be a inverse trigonometric series like this. So how do we find the sum of this type of series or this type of series? So for the first question, what we have to do is we have to rewrite the series like this. Sin A2 minus A1 is sin A2 cos A1 minus cos A2 sin A1. So that will become tan A2 minus tan A1. And if we proceed like this, the last one will be tan AN minus tan AN minus 1. So 1 by sin A2 minus A1 into tan AN minus tan A1. So this is how we can find out the sum of a series like this. Regarding inverse trigo series, suppose you have a series like this, so you can see that the general term is cot inverse 2n square. That is coming to tan inverse 1 by n square. So this is what we will get. So we can write this in another way like this. Now if we put different values of n, so we will get tan inverse 3 minus tan inverse 1 plus tan inverse 5 minus tan inverse 3 and the last one will be tan inverse 2n plus 1 minus tan inverse 2n minus 1. So this series is basically tan inverse 2n plus 1 minus tan inverse 1. So the final answer is this, which after simplification it is equal to this. So this is the topic trigonometric series, and that brings us to an end of the second session of JEE sequences and series.